welcome back. Hope you've had a good couple of lessons, a couple of days even, since our test. So today I would like to start by just scrolling through it, pointing out some sort of common mistakes, some solutions to them. And now you guys can keep that. I've got a scanned copy for SACE, so keep it, file it away. You're going to use it as a revision resource at the end of the year. Okay? So if you want a copy of these solutions, you'll find them on the Google Drive, or if I forget them, let me know and I'll upload them. And if you want a blank copy of the test, you're allowed to have that as well. Let me know, I can upload that too. Okay, so firstly, it is out of 52 marks, so I hadn't added it up properly when I printed it. So 52 marks. On page 1, I'm very happy. We all were pretty confident using the right rules. Where people made mistakes, they were sort of trivial errors. Just one person forgot to use notation. A couple people, like down here with the sine and the cos, like they just didn't bring the half out the front. So they're really happy that we're all understanding when we should use which rule and what rule we should use. All right. First principles, really happy with our performance there. That was a pretty easy one, okay, and it was the only first principles question in the test. So well done, very happy with your work there. And then down here, like on the first 2 pages, nothing outrageous, all stuff we have seen before. So finding the slope, stating its significance. If you did the practice test, you see this is like in every single practice test, so we shouldn't be getting that wrong. Okay, so again, same with the second derivative one. This is featured in a few of them. And the reason this is a good question is because it checks to see if you're going to try and use the quotient rule. So you can use the quotient rule to find the first derivative, but it just makes it a huge mess. And then you've got product rules and quotient rules going on to find the second derivative. So what you have to do here, really, to make it simple, is to split the denominator, use index laws, and then differentiate accordingly. Okay, so pretty happy with our performance there. A couple of people just mixed up a few of the fraction operations, so just a bit of a skill we need to work on. Now question 4 stumped a few people. Question 4, I think where people got stuck is they didn't use the product rule. Okay, if you use the product rule, then you were sort of able to get about 3 marks, I reckon, 2 or 3 marks, whereas if you didn't use the product rule, you didn't get very far at all. So if we use the product rule, that's our derivative, and then we want to find when the derivative is 0. All right, so I've just moved this term over, multiplied both sides by the denominator, and then I'm just solving that linear equation. The a cancels, all right, so the a is in there, but it's irrelevant to the solution. Okay, and that isn't one of the textbook questions, so if you did all the questions that I wrote down on the checklist, you would have done that question. All right, question 5. This is one that's featured in a number of different practice tests as well. I think for the past sort of 2 or 3 years, you've seen this exact same type of question. And again, really happy with our efforts there. Question 6, reasonably good. We've got cos x times e to the sine x for the first derivative, and then for the second derivative, you need to use the quotient rule, the product rule, sorry, because you've got u times v, and then there's the factorization of the common term to simplify it to the expression that they're asking for. Okay, question 7. Now this stumped a few people, and this is something I would like to talk about, is when everyone was sort of okay, I think, with getting the derivative to this level here where I've got it where my mouse is now, okay? X to the minus half times 1 take x, and then there's plus 2 root x, it simplifies to, okay? But at this step, and there's the denominator, right? And it is 1 take x squared. Okay, at this step, lots of people just chucked that straight on the bottom. All right, and the reason we can't do that is because it doesn't belong to this term as well. Okay, so what we've actually got here is we've got 1 take x on top of the square root of x plus 2 root x, and all of that is on top of the denominator. Okay, so you can't just chuck that at the bottom, it needs to belong to this term as well. All right, so that's what's going on there, that's how you simplify it. Now we actually did this problem in class because the next 2 parts were a little bit tricky. Find when determine the values for x for when the slope is horizontal. So you found the derivative function, all right, and it is 1 plus x on top of the square root of x times 1 take x squared. Okay, so this function will equal 0 when the numerator equals 0. So people were correct to do that. X equals minus 1, all right? But when x is minus 1, okay, that's a solution to the top of it. If you put minus 1 in here, you've got 0 at the top, and then at the bottom you've got the square root of minus 1, which is undefined. So there's that little trick to it. Actually, there's no solutions for it being horizontal because it doesn't exist when x is minus 1. Okay, so that requires a bit of insight. We did go over this in class together. And then in the next one, okay, it's undefined when the denominator is 0. So that's going to be when x equals 0 and x equals 1. All right, if you put 0 there, then the whole thing's 0. If you put 1 there, then the whole thing's 0. So they're the two values. And if people got the first part wrong, okay, they said this, all right, that's not the right answer. There should be no solutions. And then they wrote this. I gave them full marks here because that's correct. Okay, that's correct. But there is more solutions, isn't it? It's x being less than or equal to 0 because x can't be negative and it can't be 1. But that same error was carried forward. So just some of my terminology for you guys. ECF means error carried forward. It's where you've made an error in the past and you haven't got the same solution I've got, but you've performed the process accordingly, and so you're still awarded full marks depending on where it matches. The other one is TE, that just means trivial error. Okay, so things like forgetting a negative in a trivial circumstance, or forgetting a half here and there, they can be trivial errors. Not always, and it's when we have repeated trivial errors that you start losing marks. Tend not to do half marks. All right, question 8. I really like this question because I've come up with it. Like 8A is pretty easy, I think. Some people went and used the quotient rule and still obtained the right answer, but I said when we can use log laws, we can split it, and it's much easier to differentiate and collect that way. All right, but part B, that's the part I'm particularly proud of. All right, because part B isn't find when the slope's horizontal or find the slope when x is a number. It is find x when the slope equals 1, and so or when f dash of x equals 1. That's very precise there, the wording, and I won't go into why. So we've got minus 4 and x squared take 2x take 3 equals 1, and then we're just solving that equation. It's a quadratic. We can factorise it. The solution is x is 1. And then find the slope when x is minus 2. Everyone, like this is an example of where you can get marks even if you make a trivial error, okay? Because everyone wrote this statement, all right? And that was good, okay? But then a few people didn't simplify it properly, all right? So that's where the trivial error lies. What we're checking is, do you understand what you have to do? You have to put that x value into the derivative function so you can still obtain full marks there. Okay, and question 9 is a hard one. All right, question 9 is a hard question. We've got ln of sine of x. Okay, and so we talked very deliberately about this before the test. It exists if sine is positive. All right, because we've said ln of anything has to be positive. The function has to be positive. I've even mentioned that this is an old version that I printed, but for you guys it says, given ln of f of x is defined when f of x is greater than 0, determine the domain of ln of sine x. So most people were able to write 0 to pi, but sine is a periodic function, which means we need to consider all of the solutions. Okay. Determine the slope when x is pi on 4. Most people were fine with this. All right, so you've got the derivative function and you input pi on 4. And then the last one, determine all values of x such that the slope is horizontal. So here there were a couple of errors carried forward, but I will explain my reasoning here. We want to know when the derivative equals 0. That's when cos x equals 0. So that's at pi on 2 and 3 pi on 2. But if we consider the domain that we've written, 3 pi on 2 is not within the domain. All right, so this is the only solution, but this is the only solution that recurs. All right, so even if you didn't get, I think most people were able to earn some marks there. All right, even if they were just writing plus k2 pi, they recognised that there were all solutions that they needed to care for. All right, are there any questions about our bit of a test recap there? Hold on to them. When I'm coming around, you can ask me some questions. Try to get yourself some extra marks. But for now, let's move on to 3A.